I'm going to use unicorns to explain how population genetics works. We have an autosomal gene for unicorns that has two alleles. A big A allele will give black hoofs, a big A little a will give a gold hoof, and a little a will give a white hoof. So we have a 20 unicorn population from the mainland that are migrating to an island that has 200 unicorns on it. From this we get the migration number, and we also get the migration rate. So the migration rate is 0.91%. So our allele and genotype frequency are as shown in this chart right here for the mainland and the island unicorns separately. Both of these populations were in Hardy-Weinberg equilibrium before the shift, but as you can see, they won't be in Hardy-Weinberg equilibrium after. Now we need to assess what the genotypic and allelic frequencies of the two populations are. So to get the genotypic frequency, let's take the mainland big A example first. So you take the total number in the big A category, which is 5, and you divide it by the total of how many are in the mainland category as a whole. So it'll be 5 divided by 20, then that would be equal 0.25. And then you do the exact same thing for all of the categories, so the 3, the 12, and then you would do the same thing for the island population as well. Now to get the allelic frequency, let's take, for example, the mainland again. So you take for the big A, you want to take the 0.25 that you found in the genotypic frequency, and then I want to add it to half of the big A little a genotypic frequency because you just are interested in 1/2 of that allele. So you want just the big A, and then you add those two together and you would get 0.325. And then you just do rinse and repeat for the little a for the mainland and the big A and little a for the island. Now we need to find what the allelic and genotypic frequency changes are after the migration. So to get the allele frequency after migration, you use the formula P prime equals 1 minus the M constant times the allele frequency of the island population plus the M constant times the allele frequency of the mainland population. Once you plug all of that in, you'll get the allele frequency for the population after the migration has occurred. And to get the other allele, you just take 1 minus this constant, and you will get the little allele. Now, to get the genotypic frequency, it's the same equation for the allelic frequency, except you need to do each one of these for each possible genotype. Once you do that, you should get these answers, and if you add these all up, they should equal 1.